Hello everybody, welcome into another lesson. So today we are going to start out by discussing spheres, and then we're going to talk about traces of spheres. So first let's talk about a sphere. Well, we have a sphere graphed here in the XYZ system. It's a 3D equivalent to a circle. Well, let's break this down. First, let's take the definition of a circle. If we remember from geometry, a circle is the set of all points equidistant from a fixed point in the plane. That fixed point, of course, would be the center of the circle. And then the distance from that fixed point to any point on the circle is the radius. Well, a sphere is similar in the fact that it's the set of all points equidistant from a fixed point but in space. So you're going to have this in 3 dimensions. And the distance from that fixed point to any point on the sphere is still the radius. Now, if we cover up this z part, you just have the equation of a circle. X minus h squared plus y minus k squared equals r squared. Well, when you have a sphere, you just add this plus z minus j squared. That's the typical equation of a sphere. You just simply add the z minus j squared component. So to find your center of the sphere, you set each of these quantities equal to 0. You'll get a center at h, k, j when you set each of those quantities equal to 0 with radius equal to r. So it's a lot like dealing with a circle, only in 3D, or dealing with a sphere. So let's do a few of these here. Let's first start out by being given the center of a sphere at 0, 4, 3, and the radius equal to 3. So we're given the center and the radius of a sphere. We need to find the equation of that sphere. Well, again, it's a lot like finding a circle, only in 3D. So you're going to take each of these coordinates. So we have 0 for the x coordinate. That would be x minus 0 quantity squared, or in this case it would just be x squared, plus your y coordinate is 4, so you would end up taking the quantity of y minus 4 squared, plus your z coordinate is 3, so this would be plus the quantity of z minus 3 squared, equals your radius squared. Well, 3 squared is 9. So the equation of this particular sphere with center at 0, 4, 3 and radius 3 is x squared plus the quantity of y minus 4 squared plus the quantity of z minus 3 squared equals 9. Let's do another one here where you're given the center and the radius. So the center is going to be at negative 3, 7, 5, and then you have a radius of 10. Alright, so we have a sphere with the center located at negative 3, 7, 5. The radius of the sphere is 10. We need to find the equation of the sphere. Well, let's start with our x-coordinate. So if x equals negative 3, that means you're going to have a quantity of x plus 3 squared, plus, if your y coordinate is 7, so y equals 7, this would be y minus 7 quantity squared, plus then if z is equal to 5, this would be the quantity of z minus 5 squared, equals your r squared. Your r is 10, your radius, so that would be 100. So the equation of this particular sphere would be x plus 3 quantity squared plus y minus 7 quantity squared plus z minus 5 quantity squared equals 100. So that's pretty basic. It's a lot like finding a circle. Now, let's say this time we're just given the endpoints of a diameter. That's all we're given. So they just give you endpoints of diameter are at 3, 0, 0 and 0, 0, 6. Alright, so you just have a sphere with endpoints of the diameter at 3, 0, 0 and 0, 0, 6. We don't know the radius, we don't know the center. Well, what do we know about a diameter, whether it's a sphere or a circle? The diameter connects 2 points on the circle, or on the sphere. So that means the radius is equal to half the distance between these 2 points. Is equal to half the length of the diameter. We know the radius, again, equals half the diameter. So if we want to find the radius, we're going to take 1/2 of the distance formula between these. So the radius would equal 1/2 of that distance formula. So x2 is 0 minus x1 being 3, quantity squared, plus y2 is 0 minus y1 is 0 squared, plus z2 is 6 minus z1, which is 0 squared, which then means if we simplify this, you'll get 1/2 of the square root of -3 squared plus 0 squared plus 6 squared. So that's going to equal 1/2 of the square root of 9, 0 squared is 0, plus 36, which would end up equaling 1/2 of the square root of 45. Which this might be a good way to leave it, but we want the measurement of the radius. So square root of 45 is the same as the square root of 9 times 5. So this would end up being 3/2 times the square root of 5. So you're given a radius of 3/2 times the square root of 5. Or in this case, you could also say 3 times the square root of 5 over 2 is your radius. So now we found the radius by taking half the length of the diameter. We literally took half the distance between the 2 diameter points and we got the length of the radius. Alright. Now we found the radius. That means the center has to lie halfway on the diameter. So to find the center, we need to take the midpoint of these 2 points. So the center, then, if we remember the midpoint formula, take your x1 plus x2, so 3 plus 0 over 2, y1 plus y2, so 0 plus 0 over 2, and then z1 plus z2, so 0 plus 6 over 2, which would simplify into 3 over 2, 0 over 2, and 6 over 2, for the final answer being 3/2, or 1.5, however you'd like to write it, 0, 3. So the center of this sphere is going to be at 3/2, 0, 3. So let me write that up here, and then we're going to find the equation of this sphere. So the center we said was at 3/2, 0, 3. Now that we found the center, we know the radius, we can proceed to find the equation. So the center for the x-coordinate is at 3/2. If x equals 3/2, that would have to mean the quantity is x minus 3/2 quantity squared, plus then the y-coordinate is 0, so this will just be y squared. And then the z-coordinate is 3, so this would be plus the quantity of z minus 3 squared equals this radius squared. So let's take 3 times the square root of 5 over 2 and square that. So 3 squared is 9, times 5 is 45 over 4. So this would all be equal to 45 over 4 by the time you square the radius. So the equation of the sphere is going to be x minus 3/2 quantity squared plus y squared plus z minus 3 quantity squared equals 45/4. We'll do one more like this where we're given the endpoints of the diameter. Now let's see what they throw at us this time. Alright, so one endpoint is at 2, -2, 2, and the other is going to be at -1, 4, and 6. Alright, so the endpoints of the diameter of this sphere we're about to find the equation for are at 2, -2, 2, and -1, 4, 6. Well, again, the radius equals half the length of the diameter, so that means, yeah, radius equals half of the diameter. So the radius in this case is equal to half of the distance between these 2 points. So now take your x2 of -1 minus your x1 of 2, square that quantity, plus take your y2 of 4 minus your y1 of -2, this would turn into 4 plus 2 quantity squared, plus take your z2 of 6 minus your z1 of 2 quantity squared. Just take the square root of all that, so this would be equal to half of, if we simplify this, -1 minus 2, that would turn into -3 squared, plus that 4 plus 2, that's 6 squared, plus the 6 minus 2, so that turns into 4 squared. So simplifying further, this would be half of the square root of 9 plus 36 plus 16. So 36 plus 9 is 45 plus 16, that equals the square root of 61. So you have a radius of the square root of 61 over 2. Not a very nice radius, but that's exactly what it is. So you have the radius being the square root of 61 over 2. Alright, so we found the radius. Next thing we need to do is find the center of the sphere. Well, the diameter always passes through the center, right? Whether it's a sphere or a circle. So that means the center is going to be halfway between these 2 endpoints of the diameter. So let's use our midpoint formula to find the center. So x sub 1 is 2, plus our x sub 2 is -1, so you'll have 2 minus 1 over 2. And then you have y sub 1, which is -2, plus your y sub 2, which is 4, divided by 2. And then you'll have your z sub 1, which is 2, plus your z sub 2, which is 6, divided by 2. So this would turn into 1/2, 2/2, 8/2. So your center itself is going to be at the order triple 1/2, 1, and 4. So the center of this sphere is at 1/2, 1, and 4. So let me write that up here now since we found it. Alright, now we have the radius, now we have the center. At this point we have enough to find the equation. So the x-coordinate of the center is 1/2, so x equals 1/2. This would be x minus 1/2 quantity squared, plus, okay, y equals 1, so this would be plus y minus 1 quantity squared, plus the z equals 4, so this would be z minus 4 quantity squared, equals your radius squared. So if we square the square root of 61 over 2, you get 61/4. So the equation of this sphere is going to be x minus 1/2 squared plus y minus 1 squared plus z minus 4 squared equals 61/4. Alright, so that was all the information given about a circle and finding an equation. Now we're going to work in reverse, which if you ask me is easier. If I'm really being honest with you, I think it's easier. So what do we got here? So we start out being given x squared plus y squared plus z squared minus 5x equals 0. So we're given the equation of the sphere in standard form. We want to find the center and the radius. Well, what we need to do, like when we were talking about conic sections and circles, first get your variables all grouped together. So this would turn into x squared minus 5x plus y squared plus z squared equals 0. Now what you're going to have to do in order to get the coordinates of the center is you're going to have to complete the square on your x terms. So this would turn into x squared minus 5x. Okay, now half of negative 5 is negative 5 halves. If you square that, you'll get plus 25/4. And then you would have plus y squared plus z squared would equal that 25/4 on the right hand side. So let's just now simplify this quantity for x. You end up getting x minus 5 halves quantity squared plus y squared plus z squared equals 25/4. Now we have this equation of the sphere in a form that we can work with. We can find the center and the radius. So just set each of these equal to 0. X minus 5 halves equals 0. That'll give you the x coordinate located at 5 halves. You would get y and z are both 0 respectively. So the center would be at 5 halves 0, 0. The radius is equal to the square root of that 25/4, which would be 5 halves. So the center of this sphere is at 5 halves 0, 0. The radius would be at radius would be a length of 5 halves. Okay, let's do a couple more of these. A little bit longer of one. So we have x squared plus y squared plus z squared minus 4x plus 2y minus 6z plus 10 equals 0. So yes, we have a rather messy equation, but this should be just like doing conic sections, only we're adding the z dimension. Once again, group all your variables together, get rid of the constant term out of the left-hand side. So if we do that, you'll have x squared minus 4x plus y squared plus 2y plus z squared minus 6z is equal to negative 10. If we group all the variables together and move the constant term over to the right hand side. Now on each of these variables we need to complete the square. So for the x squared minus 4x, okay, so half of negative 4 is negative 2. If you square that, you get positive 4. So this would turn into x squared minus 4x plus 4. Now deal with the y. So y squared plus 2y, well, half of 2 is 1. You square that, you get 1. So that'll be plus y squared plus 2y plus 1. And then with that z squared minus 6z, half of negative 6 is negative 3. You square that, you get positive 9. So you'll add positive 9. Add all those numbers you got from completing the square to the right-hand side, so you would get negative 10 plus 4 plus 1 plus 9. And now we can simplify this. So the x part will become x minus 2 quantity squared, plus dealing with the y, you'll have y plus 1 quantity squared. Dealing with the z, this would turn into plus z minus 3 quantity squared, is going to equal then this negative 10 plus 4, which is negative 6, plus 1 is negative 5, plus 9 is positive 4. So now you got the equation of a sphere that you can work with. X minus 2 quantity squared plus y plus 1 quantity squared plus z minus 3 quantity squared equals 4. Now we can find the center and the radius. X minus 2 equals 0 would give you the x coordinate of the center being 2. Y plus 1 equals 0 would give you the y coordinate being negative 1. Z minus 3 equals 0 would give you the z coordinate being 3. The radius is equal to the square root of that 4, so you have a radius of 2. So this sphere has a center of 2, negative 1, 3 with a radius of 2. Let's do one more of these, then we'll move on to traces. All right. So we have 9x squared plus 9y squared plus 9z squared minus 6x plus 18y plus 1 equals 0. So we have some other coefficients this time on our quadratic terms that are not 1. But again, this is much like working with a conic section. Actually, it's the same way of doing it, working with the conic section that we did in the last unit. And technically a sphere is a conic section, it's just the 3D equivalent. But anyway, same process. Go ahead and get your variable terms together and move the constant over to the right hand side. So this is going to turn into 9x squared minus 6x plus 9y squared plus 18y plus 9z squared equals negative 1. Now, of course, what do we remember from conic sections? The quadratic term always has to have a coefficient of 1. So on the x terms, you can factor out a 9. So this would be 9 times the quantity of x squared. Now, obviously 9 times negative 6/9 would be negative 6, but if we reduce that to simplest terms, you would end up getting minus 2/3. x. And then let's deal with the y term. So the y term, we can also factor out a 9. So this will be plus 9 times y squared. This would be plus 2y. And then plus 9z squared equals negative 1. Now all that's left to do on each of these is complete the square. So we'll have 9 times that x squared minus 2/3 x. Well, half of negative 2/3 is negative 1/3. You square that, you get plus 1/9. Plus you'll take 9 times the y squared plus 2y. Well, half of 2 is 1. If you square that, you get 1. Plus this 9z squared equals that negative 1, of course, but now you got to take everything from completing the square and add it over here. Well, 9 times 1/9 is 1, so this will be plus 1. 9 times 1 is 9. So let's simplify the left-hand side. This would turn into 9 times x minus 1/3 squared, x minus 1/3 quantity squared, plus 9 times the quantity of y plus 1 squared plus 9z squared equals your right hand side. Negative 1 plus 1 is 0, plus 9 is 9. The only thing left to do is we want the coefficients on each of these quantities to be a 1. So we have to divide everything through by 9. If you do that, you end up getting x minus 1/3 quantity squared plus y plus 1 quantity squared plus z squared equals 1. Now we have the form of a sphere that we can work with. We finally got the equation that gives us the center and the radius. So if we set that x minus 1/3 equal to 0, you'll get the x coordinate to be 1/3. Set the y plus 1 equal to 0, the y coordinate's negative 1, and then z would just be 0. The radius is the square root of that 1, or in this case, just 1. So the center of the sphere is at 1/3 negative 1, 0 with a radius of 1. A very small sphere. Alright, so that's using the equation of a sphere to find the information. Now we're going to talk about something called traces. Alright, so let me start here. So find the xy trace. Find the xy trace. So let me give the equation of a sphere. So the equation of the sphere is x minus 1 quantity squared plus y squared plus z squared is going to be equal to 36. Okay, so what does it mean to find a trace of a sphere? So the idea is that this is the equivalent to taking that sphere in 3D, basically mapping it to a 2D plane. So you'll get a 2D projection of this 3D sphere, which a 2D projection of a sphere we know is a circle. So what you'll actually end up with is a circle for a trace. It's used all the time in creating maps, or even in video gaming and computer programming stuff for games. There's often you take 3D objects and you can map it into 2D and get traces. Well, to find the xy trace, so this tells you that you're going to end up getting a circle in the xy plane. That means we have to eliminate z. And to do that, you set z equal to 0. So we'll set the z equal to 0. This would just turn into x minus 1 quantity squared plus y squared plus 0 squared equals 36. Or simply x minus 1 squared plus y squared equals 36. So what you have is a circle in the xy plane. You have a radius of 6 on this circle. But your center, the only thing you don't do is take away the z variable for the center. Your center, of course, set x minus 1 equal to 0. The center will be at 1. And then you'll end up having the y coordinate at 0, and then the z coordinate's also at 0. So what you end up with is a circle in the xy plane with a radius of 6, center at 1, 0, 0. Okay, now let's say this time we asked you to find the xz trace. So yes, we're going to find the xz trace. So we're going to take this circle, map it into the xz plane, which means that we got to set y equal to 0. So this will turn into x minus 1 quantity squared plus 0 squared plus z squared equals 36, which would reduce to a circle with the equation of x minus 1 squared plus z squared equals 36. So you'll have a circle in the xz plane of x minus 1 squared plus z squared equals 36. Your center is going to be, if you set x minus 1 equal to 0, the center would be at 1. Your y coordinate is 0 for the trace by default. Whatever coordinate you set equal to 0 has an automatic coordinate of 0. And then z in this case is also 0, and your radius is 6. So the xz trace of this circle is x minus 1 quantity squared plus z squared equals 36, that circle in the xz plane, with the center at 1, 0, 0, radius of 6. And then, of course, we're going to find a yz trace. Now, it is sufficient, something I should warn you about is that finding these traces, when you get a circular projection in the plane, can change the radius of the circle. So let's find a yz trace of this circle. If we're going to find a yz trace, that means we have to set x equal to 0. So just x, you'll end up taking 0 minus 1 quantity squared plus y squared plus z squared equals 36. This would turn into negative 1 squared plus y squared plus z squared equals 36, which would give you y squared plus z squared plus 1 equals 36, which then for the final equation would give you y squared plus z squared equals 35. So notice your radius has changed for the yz trace. You end up with a circle in the yz plane with the equation of y squared plus z squared equals 35. Now let's find, of course, the center of this circle. X is 0 by default because it's a yz trace. Y is 0, z is 0. The radius is the square root of that 35, which would be just the square root of 35. So for the yz trace, you end up with a circle in the yz plane of y squared plus z squared equals 35, center at the origin, radius has a length of the square root of 35. Let's do one more of these. Traces are actually very easy. We'll start out with the xy trace. We'll do each of the traces again, but we're changing the sphere. So we're going to take this sphere, so x squared plus y squared plus z squared minus 4y minus 6z minus 12 equals 0. So here's the standard form of the equation of a sphere: x squared plus y squared plus z squared minus 4y minus 6z minus 12 equals 0. Now, we're just going to find the traces. We don't care about finding the center or radius of the sphere itself, but we do care about them for their traces. So an xy trace means we're going to take this sphere, map it into 2 dimensions on the xy plane, which means we have to set z equal to 0 for an xy trace. So let's do that. This will turn into x squared plus y squared. That z turns into plus 0 squared minus 4y minus 6 times 0 minus 12 equals 0. So to simplify this side, simplify this equation, all these zeros go to 0. This would turn into x squared plus y squared minus 4y equals 12 if we move the constant term over to the right hand side. Now, to get the form of the trace equation where we have the center and the radius, of course, we need to complete the square on the y term. So this would turn into x squared plus y squared minus 4y. Half of negative 4 is negative 2. Square that, you get positive 4. That would equal 12 plus 4. So to simplify this, you would end up getting x squared plus the y minus 2 quantity squared equals 16. So for the xy trace, you'll end up with a circle in the xy plane of x squared plus the quantity of y minus 2 squared equals 16 for the equation. The center, of course, that x squared would mean the x coordinate is 0. The y coordinate would be 2, a default z coordinate of 0 since it's a trace. And then the radius is the square root of 16, so the radius is 4. So you end up, for your xy trace, a circle in the xy plane with the equation of x squared plus the quantity of y minus 2 squared equals 16, center at 0, 2, 0, radius of 4. Next, we're going to find the xz trace. So finding the xz trace means we're taking this circle, mapping it to the xz plane, which means we need to make the y equal to 0 because we need to eliminate y to get that xz trace. So this will turn into x squared plus 0 squared plus z squared minus 4 times 0 minus 6z minus 12 equals 0. Let's simplify this. All these zeros here will go to 0, so this would turn into x squared plus z squared minus 6z equals 12, because I just got rid of the constant out of the left-hand side and moved it to the right. Okay, so now let's go ahead and complete the square on the z terms to simplify this. So you'll get x squared plus z squared minus 6z. Now half of negative 6 is negative 3. If you square that, you get 9. So this will be plus 9 equals 12 plus 9. So when we factor this in final form, you'll end up getting x squared plus the quantity of z minus 3 squared equals 21. So the xz trace of this sphere is going to be a circle in the xz plane with the equation of x squared plus x squared plus z minus 3 quantity squared equals 21. Now we can find the center. Well, the center, of course, of this trace, you just have x equal to 0 here. y is the default 0 because it's an xz trace, and then z minus 3 equals 0 would give you a z coordinate of 3. Radius would equal the square root of 21. So those would be all the specs you have for the xz trace. And yes, you guessed it, we're going to do a yz trace. Of course we are. So let's deal with a yz trace. So this time we'll deal with yz trace. So this means for a yz trace, we're going to take this circle, map it into 2 dimensions in the yz plane, which means we have to set x equal to 0 because we have to eliminate the x. So if we do that, you'll get 0 squared plus y squared plus z squared minus 4y minus 6z minus 12 equals 0. Well, 0 squared is just 0, so this would become y squared plus z squared minus 4y minus 6z equals 12 because I just moved the constant term over to the right-hand side. Now let's group our variables together. So this would turn into y squared minus 4y plus z squared minus 6z equals 12. Now we just complete the square for both variables and we can get a form we can work with. Alright, so y squared minus 4y, now half of negative 4 is negative 2. If you square that, you get positive 4. Plus you take your z squared minus 6z. Well, half of negative 6 is negative 3. You square that, you get positive 9. That's going to end up equaling that 12 plus that 4 plus 9. So to simplify this equation now, you'll have y minus 2 quantity squared plus z minus 3 quantity squared equals 12 plus 4 is 16 plus 9 is 25. So for the yz trace of this sphere, you'll get a circle in the yz plane with equation of y minus 2 quantity squared plus z minus 3 quantity squared equals 25. Which means the center, since it's a yz trace, has a default x coordinate of 0. Y minus 2 equals 0, so y would be 2. Z minus 3 equals 0, so the z coordinate would be 3. Radius equals the square root of 25, or simply 5. So those would be the specs for your yz trace of this sphere. So as you see, really pretty basic, pretty easy stuff. Now the next lesson we're going to go on to vectors in space. I know it's been a minute since we talked about vectors. Earlier in the course we talked about vectors in the 2D plane and the XY plane. Well, they do happen in the XYZ coordinate system also. So stay tuned for that. I hope everybody has a great day. Take care.